It's Matthijs here. This is a lesson where we're going to cover a couple of free response questions on the topic of Taylor polynomials. So here's our first one. This is from the 2014 BC exam, question number 6. We've got a Taylor series for a function f centered at x equals 1 is given by this sum and converges to f of x as long as the absolute value of x minus 1 is less than some ratio, or some radius, where r is the radius of convergence of the Taylor series. So the first part of the question is to just find that radius of convergence. What is the value of r? What is the radius of convergence? So, pardon me. Remember, the way to find a radius of convergence is using the ratio test. We're going to take the limit as n approaches infinity of basically the n plus first term divided by the nth term, if this whole thing is taken as a of n. And we're going to take the absolute value of that. So in this test, we can ignore the alternating piece and just look at the rest. So the n plus first term would be 2 to the n plus 1 times x minus 1 to the n plus 1 all over n plus 1. And then the reciprocal of the nth term would be n over 2 to the n times x minus 1 to the n. We want the absolute value of that. And then we just want to simplify this as much as we can. So 2 to the n plus 1 divided by 2 to the n, that's just going to be 2. X minus 1 to the n minus x minus 1 to the n plus 1 divided by x minus 1 to the n will just give us x minus 1. And then that's going to be times n in the numerator and n plus 1 in the denominator. And remember, we're taking the limit as n goes to infinity. So n over n plus 1, as n gets larger, that's just going to go to 1. These are same degree, same leading coefficient. So that piece is just going to go to 1. So this is just equal to 2 times x minus 1 in absolute value. Or if we distribute that a little bit, 2x minus 2. And then we know for it to converge, the statement of the ratio test is that this converges if this is less than 1. So we get this inequality. So if we look back at what we're trying to find, x minus 1 absolute value is less than r. So we basically want to divide both sides by 2 here and say, okay, that'll give us x minus 1. And so r must be 1/2. R must be 1/2. So that's the answer to the question. Find the value of r. R is 1/2. Okay, let's go to part B now. Find the first 3 non-zero terms and the general term for the Taylor series for f prime, the derivative of f at the same center, x equals 1. Okay, so I'm going to duplicate this page so that we can have more room to write. Part B. Okay, so I think a good strategy here, since we just need the first couple terms, let's just write out the terms of f, and we can kind of get our feet under us of what's going on here. Okay, so for example, and I'm going to keep these organized. Maybe I'll say, okay, what's n? We'll do n equals 1, n equals 2, and n equals 3, the first 3 terms. Let's look at that. If n equals 1, if we plug that in here, okay, -1 to the 1 plus 1, so the first term will be positive. Then we'll have 2 to the 1 divided by 1, so that's 2, positive 2. And then we'll have x minus 1 to the 1, so just 2x minus 1. I guess I don't really need that plus sign, but that first term is positive. Okay, when n is 2, we've got -1 to the third, so this is going to be a negative term. We'll have 2 squared divided by 2, 4 divided by 2, that's just 2. And then we'll have x minus 1 squared. Okay, and then our third term, we can see this is alternating, so this next term is going to be positive. We'll have 2 to the third divided by 3, so 8/3, and then increase the power on x minus 1 to the third power. And we could keep going, but I think we're just looking at the first 3 terms here, so I think this will be okay. And so then let's look at f prime of x, and we can find this by just differentiating each of these terms, okay? So we can treat this the same as we would treat 2x, and the derivative is just the number 2. Here we can differentiate this using the power rule. Bring the 2 down in front, multiply that, that's -4, and then decrease the exponent by 1, so x minus 1 to the first. And then same idea here, bring the 3 down in front, 8/3 times 3 is 8, and then we'll have x minus 1 squared. So those are the first 3 non-zero terms of f prime. And one way to get that is by just taking the first 3 terms of f and differentiating each one. Okay, we also need to find the general term. So I'll show you 2 different ways to think about the general term. One way to think about this is to just look at the 3 terms that you've got here and see if you can just write an expression for this sequence, like in terms of n, how would you get these numbers? So for example, we've got 2 and then 4 and then 8, right? So we've got 2 to the first, 2 to the second, 2 to the third. So we've got like a 2 to the n piece happening here. And also notice that it's alternating. So we'd also have like a -1 piece. Let's think about this. We want the first term to be positive, so it can't be to the n. It's got to be to the n plus 1 to get the first term to be positive, second term to be negative. And then we've got increasing powers of x minus 1, starting at the 0th power, and then the first power, and then the second power. So the exponents there are 1 less than the index. So we're starting at the 0 power, then the first power, then the second power. So this is one way to think about that general term, is just, okay, if this is my sequence of terms, what kind of formula would generate that? Another way to get that formula is by just looking here and taking the derivative with respect to n of the part that has x in it. So the derivative of x minus 1 to the n would be n times x minus 1 to the n minus 1. And so if we take all of the rest of this and then multiply it by this derivative, we see that these n's, we're dividing by n here, we're multiplying by n here, those will cancel. And then we've got our -1 to the n plus 1, we've got 2 to the n, and then we've got x minus 1 to the n minus 1. And so that's what we got in our general term. So another way to find that general term would be sort of thinking about how can we just differentiate our original, our original formula. Okay, so that is part B. Let's go on to part C now. And part C is going to rely on part B, so I'm not going to erase this work that we just did. The Taylor series for f prime about x equals 1 that we just found is a geometric series, okay? So we've studied geometric series. We know their properties. Find the function f prime to which the series converges on our interval or on our radius of convergence. And use this function to determine what is f on that radius of convergence, okay? So let's look back at those 3 terms. We were told that this is a geometric series, which means we're multiplying by something to get from each term to the next term. And that something is called the ratio. So what is our ratio, right? To get from 2 to negative 4 times x minus 1, what did we multiply by? Well, obviously we multiplied by negative 2 to get from 2 to negative 4. And we also must have multiplied by x minus 1 because we didn't have that here, and now we do. And let's see if that ratio holds up for our next terms. Negative 4 times negative 2 would be positive 8. X minus 1 times x minus 1 would be x minus 1 squared. So the ratio, we're told that this is a geometric series, and the ratio that we're multiplying by each time is negative 2 times x minus 1. Or you could also think of that as negative 2x plus 2. Okay, I'm using a little r here because this is our ratio, not to be confused with capital R, the radius of convergence. Okay, and so now we know something even more, which is that the sum of an infinite geometric series is the first term divided by 1 minus the ratio. And if we look at f prime of x, we know the first term is 2, and then we just found the ratio is negative 2x plus 2. So if we just simplify this a little bit, 2 over, this would become a positive 2x, and we'd have 1 minus 2 is negative 1. So 2 over 2x minus 1, that is f prime of x. That is our function. Okay, so find the function f prime to which the series converges. Well, by using the first term and then the ratio, we can say what the sum is, and that's gives us a function. So that answers that question. And this is still on that same ratio. Sorry, on the same radius. R is still 1/2, same radius. And then we just want to use this function to determine f. So if we have f prime, well, f is just going to be the antiderivative of that. Okay, so we can recognize this is the 1 over x form. So the antiderivative there is just the natural log of 2x minus 1 plus c. And then we just want to find c. So how can we do that? What information do we have? Well, we know that this is centered around x equals 1. This is centered around x equals 1. So if you plugged in 1 here, you'd have 1 minus 1 is 0. And so this would all just be 0, right? So we know from the original function that f of 1 equals 0. And that's because 1 is the center of our Taylor polynomial. It's centered at 1. So we can use that. ln of 2 times 1 minus 1 plus c equals 0. So 2 times 1 is 2, minus 1 is 1. ln of 1 is 0. So this just gives us that c equals 0. Therefore, f of x is the natural log of the absolute value of 2x minus 1. That'll be on the same radius. So we can find the function by just taking the antiderivative of f prime that we just found.